Hey, y'all, let's talk about the y-intercept when we're working with um, quadratics and writing out our 9 things that we know about them. Okay, so our y-intercept is going to be where the parabola touches the y-axis. Okay, so right here, this vertical axis that goes up and down is our y-axis, this one here. So that right there is going to be our y-intercept. It's going to be a point. So if we're asking you for the y-intercept, you can go ahead and kind of draw your parentheses, comma, and when you're going to know something right off the bat about our y-intercept. Just like when we talked about x-intercepts, and you can go back and watch my x-intercept video if you haven't seen it. I'm not going left or right any when I'm finding my y-intercept. I'm just going up or down because it has to stay on this y-axis. So for my x value here, it's always going to be 0. I'm always going to have a 0 in that first number. So if you're writing your 9 things out for Mr. Deeds, and you get to y-intercept, you can automatically put a 0 there for that x value. We just have to find the number here, the second number, the y. So unlike our x-intercepts, which you can have 0, x-intercepts 1, x-intercept, or 2 x-intercepts, our y-intercept, we're just going to have 1, and you'll always have 1. So for your y-intercept, there's a few different ways you could find it. You could obviously type it into Desmos and graph it and find it that way. Or if you are given an equation, so I'm just going to make one up here. -2. If you're given an equation, the way that we've kind of suggested that you do it in class is, well, we know we have a 0 here for x, so I could plug a 0 in all these places that I have an x. And so we've practiced typing this in the calculator, and you could also do it by hand, which would be perfectly fine. And I don't think Mr. Dietz has told you yet that the top secret sheet method here, tip or trick or whatever you want to call it, to figure out what it is. But if you notice, if I kind of solve this here by hand, I'm going to end up getting a 0 there for 0 squared times 2, plus 3 times 0, which is 0, minus 2. Okay, so y ends up being just -2. Well, let's look at what we had here to start with our equation. So if I look at my equation, that last number there, it was -2. And my y value here ends up being -2. And it's not just like a coincidence. It doesn't just happen that way. It's math, really. But if you look at the standard form of the quadratic equation, my c value, the number that's by itself down here, the number by itself, we also can call this our constant, the number that's by itself at the end. That is going to be your y-intercept. You can always, if you're given any kind of equation, and it doesn't even necessarily have to be in standard form. If I was given y equals, 4x squared plus 2x plus 1, I know that my y-intercept for that equation is going to be 0, 1, because my c value is 1. So you're welcome to graph it. You're welcome to plug 0 in for your x and solve for y. But if it's written like this, we can automatically just know that our y-intercept is going to be equal to our c value. No math involved. It should be pretty simple, pretty quick, and easy to find. So if you have any other questions about your y-intercept, or you want some more examples, feel free to let me know and we can